For number 13, it says find the GCF and factor it out. So first I need to figure out what goes into 16 and 8 evenly. And there's a lot of numbers. We can do 2, 4, 8, but we want the greatest. So it looks like 8 would be the greatest number that divides into 8 and 16 evenly. Then I look to see, does both of these terms have an x? And they do. So if they do, you take the lowest x out. So 8x squared, that's my GCF. But to factor it out, this is when you put it in parentheses. So we'll put parentheses, and we're going to divide and subtract. So 16 divided by 8 is 2. 3 minus 2 is x to the first. 8 divided by 8 is 1. And then 2 minus 2 is 0, so I don't write that x down. Now, looking at my final solution, I really don't need to have this 1 there. If you leave it, that's okay to leave. Okay. Number 14, to factor this is the one that was like the special square roots, difference of squares. And so we set this up as 2 sets of parentheses. I asked you guys, what's the square root of x squared? And you guys would tell me it was x, because x times x makes x squared. And then what's the square root of 49? And that's 7. So 7 times 7 is 49, but I have to have a negative 49. So I need a positive and a negative to get me back to negative 49 when multiplied together. Okay, now, looking at these 4 questions. On these 4, you have to decide like if you're using x factor or x factor with bottoms up. So if I look at 15 and 16, I see that I have a 1 in front of x squared. So these are regular x factor. So I do the first number times the last number. So 1 times 18 is 18. And we need to get to the middle number, 9. So we look at our factor sheet, or you could list the factors of 18 here. So 1 times 18, 2 times 9, 3 times 6. And I want to know what pair can add or subtract to make 9. And that would have to be 3 and 6. Okay, now, for 3 and 6, they're going to both be positive, because if I add 6 and 3, I get positive 9. If I multiply them, I get a positive 18. We can also see that the problem here has no negatives in it. So your solution comes from these 2 factors, and we say x plus 3, x plus 6. And if we were to multiply these, we would get back to that solution. Okay, let's try it again in number 16 with a negative. So the first number times the last number gives me negative 28. And I need to get to a 3. So on the factor sheet, or you need to list the factors of 28, we have 1 and 28, 2 times 14, and 4 times 7. So which pair can add or subtract and make a 3? So you got to work through each one, like that would be 29 added or 27 subtracted. So it looks like 4 and 7. Now, I have to get a positive 3. So out of these 2 numbers, the bigger number has to be positive. So I need to make the 4 negative. So 7 minus 4 is 3. Positive times negative is negative. So again, my answer comes from this negative 4 and that positive 7. Okay, now in 17 and 18, we have x factor with bottoms up. So I'm going to go with the first number times the last number. 3 times 4 is 12. And we have to get to the middle number, 13. So the factors of 12 are listed here. Which one can get to a 13 if added or subtracted? And that would be 1 and 12. But we also see that we have a number bigger than 1 in front of x squared. So when this number is bigger than 1, we need to do x factor with bottoms up. So So how do we do that? We write this in factored form, x plus 1, x plus 12. That first number we divide. Okay, so 1/3. Can 1/3 divide? No, it can't. It would get a decimal if you did 1 divided by 3. It can't reduce. So you bring this bottom number up, and that would be 3x plus 1. Then this one, same thing. Can you divide? Yes, 12 divided by 3 is 4. And so I would have x plus 4 as my second factor. So this is factored form. And again, if I were to do like the box method, like the 2 by 2 square, and multiply this, I'd get back to this. All right, number 18. So first number times last number gives me negative 18. I have to get to the middle number, 7. So the factors of 18, 1 times 18, 2 times 9, 3 times 6. Which one can add or subtract, which pair can get to 7? And that would be 2 and 9. So 9 minus 2 would get me 7. So the bigger number would have to be positive to match the positive 7. And they would multiply to get to negative 18. So now we write that in factored form. We see that this number is bigger than 1. So that means I have to divide by that number. And I ask, can I divide? No. Can I reduce? No. So I have to bring the bottom up. Okay, here, I can divide that. And 9 divided by 3 is 3. Okay? Then for 19, this is when you have 4 terms. So 4 terms, we called this factor by grouping. And that was when we cut it in half, and we found the GCF of each side, each group basically. So I asked myself, okay, what goes into 10 and 25 evenly? And it has to be 5. And both have an x, so I take the smaller x. Then I find the GCF of this side, which is 3. Now, these two GCFs you bring together down here, and you say, okay, well, 5x squared plus 3 is your first factor. Then, to get the second one, we divide this part here. So 6x divided by 3 is 2x. And 15 divided by 3 is 5. This side is usually a little bit easier to divide than this side, but you want to go back and check it. So like 10 divided by 5 is 2. If I subtract, I get x to the first. 25 divided by 5 is 5. And 2 minus 2 makes 0, so I don't write that. So since you divide on both sides and get the same answer, that is the second set of parentheses. It has to match when you divide both times. All right, number 20. Again, factor by grouping. I know that because I see I have 4 terms. So cut in half, GCF of each side. So this one's a little bit trickier. I'm going to go with 6 for this one. I can see you saying 2 or even 3. But 6 goes into both of them, and it is the greatest number. And then we got that x squared we can take out. For the second side, we're going to use 5. All right, so that's your first parenthesis. And then we're going to divide. Divide again. Check it here. Okay. And it matches, so this is my GCF, this is what I get when I divide by the GCF.